Hello students, welcome back to JJ's physics class. Today we are going to discuss important questions and numericals from wave optics. Let us start. The important formulas as follows. Snell's laws of refraction, as we know that refractive index of medium is equal to speed of light in the first medium to speed of light in the second medium. Relation between phase difference and path difference, that is delta phi is equal to 2 pi by lambda into delta x. So delta phi is the phase difference and delta x is the path difference. From Young's double slit experiment, we have the fringe width. We are also represented by beta, or W is equal to d lambda by d, where d is the distance between the slits and the screen and small letter d is the distance between two slits. For constructive interference, these are the conditions for phase difference and path difference, and for destructive interference, these are the conditions for phase difference and path difference. Diffraction due to a single slit, as we know that the angular spread of the central maxima is 2 lambda by d, or width of the central maxima is 2 lambda d by d, where d is the distance of the slit from the screen and small letter d is the slit width. And condition for minima, d sin theta is equal to n lambda, where n is equal to 1, 2, 3. For intensity of light due to polarization, I is equal to I naught cos square theta, and Brewster's law is given by mu is equal to tan theta p, where theta p is the polarizing angle. According to Rayleigh scattering, it shows that the scattering of light is proportional to the fourth power of frequency or inversely proportional to fourth power of the wavelength. Next is coherent and incoherent addition of waves. We have the intensity I is equal to I1 plus I2 2k E1 and E2, where E1 and E2 are the electric fields at a point due to the force, and total intensity will be sum of I1 plus I2. The average of the total intensity will be, I is a vector quantity, so I vector is equal to I1 plus I2 plus 2 square root of I1 I2 cos phi, where phi is the phase difference. Next, question number 1. How does the fringe width of interferent fringes change when the Hall apparatus of Young's experiment is kept in a liquid of refractive index 1.3? The answer is, as we know that the fringe width beta is equal to d lambda by d, when refractive index is equal to 4 by 3, the wavelength decreases to lambda by 4 by 3, or the corresponding fringe width decreases to 3 by 4 times. How does the angular separation of interference fringes changes in? Question number 2. How does the angular separation of interference fringes change in Young's experiment if the distance between the slits is increased? Answer is, angular separation theta is equal to lambda by d, or theta is inversely proportional to d. Therefore, when separation between two slits is increased, the angular separation decreases because they are inversely related. Question number 3. State the reason why two independent sources of light cannot be considered as coherent sources. Because coherent sources are defined as the sources in which initial phase difference remains constant, but in the case of two independent sources, the initial phase difference cannot remain constant because light is emitted due to millions of atoms and their number goes on changing in a quite random. Next question. How does the angle of minimum deviation of a glass prism vary if the incident violet light is replaced with red light? As we know that refractive index is inversely proportional to the wavelength of the light. That means wavelength of red light is greater than that of wavelength of violet. Therefore, refractive index of red is less than that of refractive index of violet. Therefore, angle of minimum deviation is directly proportional to the refractive index, hence will decrease when replaced by red light. Question number 5. If the angle between path axis of polarizer and the analyzer is 45 degree, write the ratio of the intensities of original light and transmitted light after passing through the analyzer. The answer is, the intensity of the light after passing through the polarizer, as we know the formula. So I naught cos square phi, where phi is 45 degree. What is cos 45 is 1 by root. If you substitute the value of cos 45 degree, 1 by root 2 whole square, so what you get, I by 4 is the answer, where I naught is I by 2. Next question. Unpolarized light is incident on a plane surface of glass of refractive index mu at an angle I. If the reflected light gets totally polarized, write the relation between the angle I and refractive index mu. As we know that the reflected light gets totally polarized with a polarizing angle, that is mu is equal to tan IP, where IP is the polarizing angle. So according to Brewster's law, mu is equal to tan IP, which is equal to tan I. Question number 7. What type of wavefront will emerge from a point source, and second one from a distant light source? The type of wavelength emerging from point source is a spherical wavefront. As you can see here, these are the spherical wavefronts. But from a distant light source, it will be a plane wavefront. So these are the plane wavefront. Next question. Draw a diagram to show refraction of a plane wavefront incident in a convex lens, and hence draw the refracted wavefront. So here you can see the incident plane wavefront is passing through the convex lens. So the transmitted wavefront will be spherical in nature. So you must draw this arrow mark and also mention the focal length and incident plane wave. Next, at what angle of incidence should a light beam strike a glass slab of refractive index √3 such that the reflected and refracted rays are perpendicular to each other? The refracted and reflected rays are perpendicular to each other at polarizing angle. So from Brewster's law, we have IB is equal to tan inverse of n or tan inverse of √3. When you substitute the values, you get it as 60 degree. Question number 10. Differentiate between a ray and a wavefront. So a wavefront is defined as the locus of all points of the medium which vibrates in the same phase, but a light ray is a straight line path drawn perpendicular to the wavefront. Question number 11. How would the angular separation of interference fringes in Young's double slit experiment change when the distance between the slits and the screen is double? Here the angular separation theta is equal to lambda by d, and it is independent of the slit screen separation, so it will be remain unchanged, or there will not be any change. Question number 12. How does the angular separation between the fringes in a single slit diffraction experiment change when the distance of separation between the slit and the screen is double? So in single slit diffraction experiment, the angular separation is given by theta is equal to lambda by a, where lambda is the wavelength of incident light and a be the slit width, so which is independent of the separation of slit and screen. Therefore, the angular separation will be unchanged. Question number 13. In a single slit diffraction experiment, the width of the slit is made double the original width. How does this affect the size and intensity of the central diffraction band? The answer is, if the width of the diffraction slit is double, the size of the center diffraction band will become half and its intensity becomes 4 times its original value. So here is the proof for that explanation. Here you can see that the intensity will be 4 times the original intensity. Next, how does the fringe width in Young's double slit experiment change when the distance of separation between the slit and the screen is double? The answer is, as we know that the fringe width is beta is equal to lambda d by small letter d, where capital letter D is the distance between slit and screen is double, then the fringe width will be double. Next question. In what way is plane polarized light is different from an unpolarized light? So you must write any of the differences. In plane polarized light, the electric field oscillates in one direction only, but unpolarized light, the electric field that oscillates in every direction. In polarized light is naturally coherent, unpolarized light is incoherent. Intensity of the polarized light is determined by the type of light is used. Here the intensity of unpolarized light is determined by the source. Question number 16. In a single slit diffraction experiment, the width of the slit is reduced to half its original width. How would this affect the size and intensity of the central maximum? As we know that the fringe width is given by lambda d by d, as the width of the slit is reduced to half its original width, the size of the central maximum will be double. We also know that the intensity is proportional to the area of the diffraction band. the size become twice and the intensity I is proportional to a square. What we get, I dash is equal to a by 2 whole square, which is equal to 1 by 4 a square or 1 by 4 I. So the intensity becomes 1 by 4th of its previous value. Therefore, the size of the central maximum will be doubled and intensity will become 1 by 4th of its previous value. Next, question number 17. Which of the following waves can be polarized? Heat waves, second one sound waves. Give reason to support your answer. Here the answer is heat waves can be polarized because they are transverse in nature. But sound waves are longitudinal in nature and hence cannot be polarized. Next question. Define coherent sources which are required to produce interference pattern in Young's double slit experiment. As we know that coherent sources which emits a light wave with the same frequency, wavelength and constant phase difference is known as coherent sources. These are the key points. Same frequency, wavelength or phase or having a constant phase difference. Question number 19. Define wavefront. So wavefront is defined as the locus of all particles of a medium which are vibrating in the same phase. Question number 20. Draw the shape of the wavefront coming out of a convex lens when a plane wave is incident on it. So you must draw the diagram here. So this is the incident plane wave, this is the convex lens and spherical wavefronts are coming out of the convex lens. So draw the arrow mark, mention the spherical wavefront, incident plane wave, etc. Question number 21. Draw the shape of the wavefront coming out of a concave mirror when a plane wave is incident on it. The answer is, this is the plane wave and it's a concave mirror. So the spherical wavefront is coming out of this concave mirror. So draw this diagram. Thank you.